Hi, I'm Don Carpenter, and I'm the retired service manager for GatesAir and Harris. And we're here today outside the new facility for WGEM TV and KHQA TV, their transmitter site right outside of Quincy. And I have here with me Brent Clingingsmith, Chief Technology Director of WGEM, and Steve Rossiter, TV Product Line Manager for GatesAir. So we're going to take a tour of this facility this morning, and I hope you folks enjoy it. Fellas, are you ready? Well, Brent, can you tell us something about the history of this facility and also something about the history of your old WGEM TV and FM site?
Yeah, definitely. I know a lot of the history from the WGM site, just obviously from that being our main, as far as facility that we've been in. Both these sites were built, in the early 50s. Both stations went on the air September of 1953, and these are both state-of-the-art buildings when they were built in the 50s. And we've had to do some upgrades since then, obviously, as technology changes. Cooling is a big issue that we've had to change. Back then, it was just everything was air-cooled. And it's amazing the transformation as far as how things have changed over the years, that we've had to, add on some places in this building to make those adequate for what we've done, with the changes that we've made.
Well, thanks, Brent. Now let's take a look at this newly constructed site. Boy, I remember back in 1975 coming here as a Harris service engineer, and we had just installed a Harris BT 50H2 for KHQA Channel 7. So if you can give us some insight on your old site, that would be great.
Yeah, definitely. I don't remember it myself because I wasn't around at that time. But the relationship that WGM and GatesAir Harris has had over the years, we've been very lucky to be kind of a test bed at some times. And we had the BT35, which was essentially a prototype, and we put that out in the air. That was a great test bed for GatesAir at the time. To be able to put that on the air. It was great for WGM. That was state of the art at the time. But we've had other transmitters, the TV50 that we've had on the air, that was a little bit more established when we put that on the air. But even as early as the early 2000s when we went to DTV, that was also a prototype with the VAX 9000 that we put on the air, which was really cool to be able to do that, have GatesAir in our backyard, and to utilize those resources. And I feel like we helped each other. It was a good relationship to be able to have this new transmitter on the air, good testing for you guys, but it was a great benefit for us to be some of the first in the market to be able to do, those sort of things with you guys.
Right, and I remember when the DTV started around 1998, we had also a diamond transmitter on UHF, I think channel 54, and you broadcast on channel 54 for about 10 years until 2009 when you went back to channel 10 on a Harris Platinum transmitter for VHF.
Yeah, that's right. Yeah. The diamond was great, and honestly where we started putting on the HD was down at the studio. We had a small orange panel for an antenna, and this goes back to '98 that we were working with at Harris at the time, that we did cover the John Glenn launch when he went into space, and watching that, I think we watched it out at was at QHS, I believe. We were in the auditorium there, and to see that, it was Walter Cronkite was the one hosting that, and it was just amazing to see the quality and the detail. You could almost count the hairs on his mustache. It was such an awesome thing and such a groundbreaking thing. I've actually, I think GatesAir had put together a small placard that had pictures of that and details. I still have that hanging in my office. That was just such a cool moment in time and great history, and something that we're definitely proud of. And then from there, yeah, we moved that to our tower and kept growing from there. From the diamond, then we went a little bit more power, put a bigger antenna up, went to the platinum, you know. So it was just a gradual progression, and then going to the VAX 9000, and then obviously moving up to the transmitters that we have today.
Now, Steve, can you tell us about the planning of the project that went on here, the proof of performance that followed, and everything that went into this facility?
Yeah, absolutely. Don, actually, there's a lot that goes on when we go to put a new transmitter in. We come out and we actually look at the site, and we work with WGEM and whoever the site owner is, and we make sure that, you know, that the transmitter that we're going to be putting in there that they require will actually fit, where to put the RF and all that. Then we go back and we actually do a drawing, and we do those drawings based upon that site review or site survey. And then we go back and forth. There's a little bit of a back and forth between WGEM and GatesAir to make sure that that meets the needs of them. So they may want to move the transmitter around a little bit, move the RF system around a little bit to make it fit. But then after we get that done, then we work with the installer with those drawings and actually install that transmitter in the room. And it's still a lot of work back and forth because there may be minor changes or adjustments. And then once that's done and we've got the transmitter up and operating, then we can go ahead and do the proof of performance to meet the FCC requirements. And then just make sure that everything's working correctly as it's designed to.
Thanks, Steve. Now let's take a look at this new GatesAir transmitter.
All right. So the transmitter that we have here is a ULXTE-80. It is a liquid-cooled transmitter designed for WGEM. In the blocks, each one of these blocks contains amplifiers. It has 10 of them. So we have 8 blocks. In here we have all the amplifiers. There's 10 of those with 10 power supplies. The phase and gain modules right here are a little amplifier, and those actually drive all of these PAs. Only one of these is used at a time, so it adds redundancy. Now all the power supplies, you'll notice there's one per each individual amplifier, and all of these are diode ORed together so that they provide power to the phase and gain. Up above that, you'll find that we have a controller. This is a software controller. It controls each one of the blocks. Each one of the blocks also has a hardware controller. That hardware controller is right here. Really, the heart of this transmitter is going to be the exciters. There's what takes the video and audio data and puts it, modulates it, and then sends it through the amplifiers. From there, it gets amplified and then combined all together and goes up to the antenna and the combiner. But we probably should go ahead and show the back of this transmitter at this point. So in the back of the transmitter, we have the 3 blocks that you see, and as I said earlier, these are liquid-cooled blocks. We have liquid reject loads for each one of the combiners. Here is the actual combiner. There's a 3 dB combiner here and a 4.77 dB combiner here, combining all of these blocks together to an output. Then we have a low-pass filter above there. We're coming out of the low-pass filter and going into the mass filter. Mass filters are designed to meet the FCC requirements so we don't interfere with neighbors. WGEM does have neighbors that are in the area with channels that are close. We don't want to interfere with them. After that, we go through additional hybrid combiners. There's one here, and there's another one up here. Those combine all the cabinets together and then out to the combiner, and then from the combiner up to the antenna. So pretty straightforward. Now there are liquid cooling pumps and heat exchangers outside. We need to get the heat from the cabinets outside.
Thanks, Steve. Now, Brent, can you tell us something about once the transmitter leaves to the output of the combiner to combine WGEM and KHQA signal?
Yeah, this is something new for us. We're taking our channel, 19 in this case, and we're combining it with 22. So we've never had that with WGM before. It's just been our signal. So it's something new for us with adding another channel and combining it. So that what Steve had talked about with the 3 cabinets being combined, then at this point we're going, Steve's going to show you where we combine both of those channels. So what's really neat about that, with combining those channels, when we go up the tower and one antenna, is that signal is going out to the viewers at home over the antenna, and they're getting the same signal in their home. So if you're getting WGEM, you're going to pick up KHQA as well, and going to have the same signal strength at home.
Thanks, Brent. Now, Steve, can you tell us some of the details about this dielectric 2-channel combiner for channel 19, WGEM, and KHQA, channel 22?
Absolutely. First, we have the output from the transmitter, which is a 6-inch line that runs over and goes through a switch. Well, from the switch, it can either go to the combiner or it can go to a load. That allows us to do testing into the load. Now, when we're in the combiner, this is a dielectric manifold style combiner, so it has filters just similar to the FCC filters that we talked about earlier. These filters actually allow this channel specific combining at the end here where you see the T. From the output of the T, we then go across and then we can go out to the antenna. And there's some additional sampling and things like that that go from that output over to the transmitters to tell the transmitters that they have a good output.
Well, thank you, Steve, on an explanation of the output combiner. Now, Brent, can you tell us a little bit about the WGEM TV signals and the multiplexing that goes on with your contents for ATSC1?
Yeah, absolutely. What Steve was showing you earlier with those exciters, we send that signal out, via fiber, via a microwave in this case. So what happens out in the studio is we have 4 signals that we feed, our NBC, CW, Fox, and MeTV. Those are all 3 HD signals, NBC being a 1080i, the other 3 being 720p. Those are all ran out of master control. Each one of those has a playlist that we run shows and our commercials, and then those are all combined into an encoder. So what we've done back in the day when we added MeTV and CW, we made those HD, and we were actually the first station in the country to be able to do 4 HDs. And it was kind of fun working with Imagic Communications, which we've had a great relationship even going back to the Harris days and before they separated. But working with guys like Dave Buck, we were able to be a test bed for them and also for us. And being one of the first, in the country to be able to do the 4 HDs, it was kind of fun being able to test those and adjust the bandwidth and to make those eventually viewable to put on the air, which was something people said you weren't going to be able to do, and we were able to do that. And we'll show you a little bit more about that as far as how we stat buck. So you take those 4 signals, 1080i, the NBC obviously eats a little bit more bandwidth than the 720p's do. But basically you take those 4 signals and they share a bandwidth. And there's 19.6 meg bandwidth, and you have to share those bits to be able to put out the best signal. And it's pretty neat to see as far as what we were able to accomplish back then with the Imagic Communication Flexicoder and putting those encoders all together and put out one great signal.
Okay, well, Steve, after we leave the transmission part of the presentation, we move to the cooling for dissipation of the heat from the transmitter system. And can you walk us through that cooling system for us?
Oh, absolutely. So the cooling system is liquid. We use a 50-50 ethylene glycol and water. The important part about the cooling system on this is the transmitter is about 40% efficient. And because of that, there's 60% that is either going up the tower or is being dissipated as heat. So we have to get that heat out of the building. So we use pumps. The pumps, we have 2 of them in each one of these pump modules. One pump is only required to be operated at one time. The other pump is sitting in standby. We also have some inverters that control the speed of those pumps, because we vary the speed of the pumps and we vary the speed of the heat exchangers outside using those inverters. And that's also to help the efficiency of the transmitter. The other thing about this transmitter that's a little different than a lot of other ones is we use solid copper plumbing for this instead of hose or other means. So this one actually looks quite neat because it's actually done with solid copper, or what we call press fit installation. These are the heat exchangers for this transmitter. There is one heat exchanger per pump module, one pump module per cabinet of that transmitter, and we vary the speeds of these heat exchangers. The one thing that's nice about this whole system is there's dual pumps as well as dual fans on these heat exchangers. So we add additional redundancy because these are working in parallel, the pumps are anyway, working in parallel, and then we have two fans in each one. So we only need one pump running at a time. We really can cool this with only one fan running at a time. That allows us to have redundancy in the system.
So Brent, now we're outside and we're looking at the vertical run up the tower, the horizontal run coming out of the building. How many feet is this tower, do you think?
The tower is 700 feet, and with the antenna is just a little bit over 80 feet. And you can see coming out of the side of the building is our 8-inch vertical line that we were showing you inside. Basically goes up the side leg of the tower, and that's what's feeding all the way up to the antenna. And that antenna is both channel 22 and 19, and that's how we broadcast both channels.
And you also have your FM antenna up there, right?
It is, yes, and it's coming out on a piece of Helix that's 1 5/8, and that goes also up a leg of the tower, and then feeds the 8-bay antenna that is up there.
So Brent, not only do we have two high-powered TV transmitters at this building, but we've also got your FM transmitter, WGEM FM 105.1. Yeah, can you tell us a little bit about what you had before and what you've got now?
Sure. The best part is what we have now. We have the GatesAir GX10, which is in the rack that we see here now, and you can see that the size of this transmitter is only what we call rack units, and it's only five rack units long. There's a good airflow between that pulls from the front and blows out the back. To give you a little bit more of an idea as far as size goes, we had it was the Harris HT10 transmitter, and it was a full cabinet, almost about 1.5 size of the cabinets of the TV transmitter, and that was a tube type transmitter, and was on the air since 1993. Very good transmitter, very good solid transmitter. And with the move here for TV, it was a great opportunity for us to be able to upgrade our FM transmitter, and the efficiency, the size of this, and it's been just a great thing for us to be able to upgrade that and to get FM out for our listeners as well.
That's right, boy. I remember the size of FM transmitters and the efficiency, and now we've got a 10 kilowatt transmitter in a rack. Amazing. It
is amazing, and it has the same remote capabilities, you know, as far as we can get into this anywhere. I can get in with my phone if I need to and check and raise and lower power, but it's a great device. It works perfect for us. We get the same signal coverage, if not better, than what we did before, and it's an amazing transmitter, and it's efficient, and it's one of those things that Steve and the crew at GatesAir have built that is just efficient, and it runs and gives me peace of mind knowing that this FM transmitter is going to be on the air, and very little maintenance that we need to do to make sure. Obviously, there's the cleaning of filters, going through and checking, making sure everything's working right. But rest assured, 99% of the time, it's working right.
Great.
All right, I would like to talk a little bit about the facts a little bit. This is a brand new transmitter. This is completely solid state, high efficiency amplifier, and it actually has an efficiency above 70%, which is fantastic for modern day amplifiers. The other thing I want to point out about the TV transmitter is this is also a completely solid state transmitter with high efficiency amplifiers, and GatesAir in general takes great pride in the products that we sell and the products that we provide to our customers. So it's very important that we give thanks to all the team at GatesAir, as far as the engineering team, the service team. Carl Williams was one of our guys that installed this transmitter, did a fantastic job of that. Also, our operations team and manufacturing, they even signed this for WGEM because we have a wonderful relationship with WGEM, and we want to make sure we keep that relationship for many years to come.
So Steve, I 100% agree with what you said. The relationship that GatesAir, going back to the Harris days, has been amazing with WGM and Quincy Broadcasting back in the day, and has carried on with Gray Media as well. I remember I personally don't remember the VT35, but I did work with it, but when it was installed, it was serial number 0. We had that with our VAX 9000 as well. It was kind of the prototype, and that's the best thing too for us being in Quincy and GatesAir being in Quincy. That's something you guys are developing, and we're the real on-air test for you guys, but that's also a great benefit for us. You know, we're testing out the latest and greatest interventions that are coming from you guys, from your engineers, from your factories that people have put together. You know, the sign door that you've shown are the people that put in those hard hours to be able to do that. And for us to have that kind of relationship with you guys has been awesome over the years. You know, I've been with the company over 30 years, and the relationships, the people that you have dealt with and worked with over the years, that you can able to call, to text, to run down the road, pick up a part, has just been amazing over the years. And we look to continue, you know, that relationship with GatesAir. And we buy GatesAir transmitters and recommend GatesAir transmitters. So the relationship is great. You guys build great products, and we're super proud and happy to be partners with you guys for many years and many years to come.
And the GatesAir team feels the same way, exactly. So
Awesome.
Well, Brent, this facility takes a lot of AC electrical power. So can you tell us something about the room here with the changeover and everything about it?
Yeah, definitely. This there is a lot of power. So coming in from Ameren, we have 480 volts that's coming in. This is the main breaker. So then we had to upgrade. KHQA did have a generator out here. There wasn't enough power to provide full power to each stations. And with us being a megawatt coming out, we wanted to be able to stay on that full power during generator usage during a storm or things of that nature. So with that, we need to put in a new generator, a new changeover switch, and that sort of thing. So this is a generator changeover switch. So it's automatic when we lose power, main power from Ameren, that this will automatically detect that, fire up the generator and switch over, and then it's seamless. There may be a few seconds where we're dark and off the air, but the transmitter knows that. It'll kick back up once power is restored, either from the generator or from shore power from Ameren.
So Brent, we've seen the inside AC distribution, and now we're walking outside here, and I see this big Caterpillar AC generator. Can you tell us a little bit about it?
Yeah, what I was describing outside, this is a 500 Caterpillar generator. It's brand new that we installed. Not me personally, but we had this installed. But this is what I was talking about inside. Basically, with the loss of power, the switch detects that. This unit will fire up once it's up to speed, which is rapidly. It will kick in power, and then the switch inside will recognize that the generator is powered there, backup power, and that will kick this generator on. It's diesel, and it has a 500-gallon tank, so it will run. Obviously, if we're going to be on it for a long period of time, it can be filled, you know, while we're running on it. We can have a fuel truck come in and keep us on the air.
Stay on the air 24/7 for free over-the-air television.
Yes, sir. Yes, sir. That's our plan.
Yes. Well, guys, Brent, Steve, I really appreciate you visiting here with me on this tour. And I know the people that attend the GatesAir Harris award ceremony in October will really get a good kick out of this presentation. And I think they'll really enjoy it. Thank you very much, gentlemen.
Thank you.